In this video, we'll explore some exponential equations. We'll start off with number 9. If you notice for number 9, the bases of 2 are the same. If the bases are the same, then you can set the exponents equal to each other. So since the bases are both 2, you can set x plus 7 and 6 equal to each other. And you can solve for x. So subtract 7 on both sides, and you get x equal to -1. What you can always do to see if you did the work correctly is substitute the value for x back into the equation to see if that is the answer. So if we put -1 for x, we would have 2 to the exponent -1 plus 7 equals 2 to the 6th. -1 plus 7 is 6, so we get 2 to the 6th equals 2 to the 6th, so that checks. Our solution would be x equals -1. If we look at number 11, it says 2 to the exponent x is equal to 0. Well, let's do an investigation here of what is 2 to the 4th. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the 1st is equal to 2. So you notice a pattern from 16 to 8, from 8 to 4, from 4 to 2. In each case, it's going down by dividing by 2. So if we do 2 to the 0, so that would give us 1, right? 16 divided by 8, 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1, and you keep going. 1 divided by 2 is 1/2, that would be 2 to the -1, and so on. So you will never get anything to the exponents will give you an output of 0. Notice it keeps going 1, then 1/2, then the next one will be 1/4, and then 1/8, and 1/16, but it will never quite get to 0. It will approach 0, but it will never quite get to 0. Using that same logic, we'll do it again. 2 to the 4th is 16. 2 cubed is 8. 2 squared is 4. 2 to the 1st is 0. Oops, sorry, is 2. 2 to the exponent 0 is 1. 2 to the -1 is 1/2. 2 to the -2 is 1/4. 2 to the -3 is 1/8. So notice that these numbers here keep getting smaller and smaller and smaller, but notice all these numbers are approaching 0, but they're not quite getting to 0, which means that they will always be positive. So they will never be a negative number. So there is no value of x here, which will give you an output of a -4. So this one would also be no solution. For number 13, if you look, the bases are both 2. Since the bases are the same, you can set the exponent of 2x and 6 equal to each other. So you have 2x equals 6, divide by 2, and x will equal 3. Again, it's a good idea to double check your work. So 2 to the exponent 2 times 3, should substitute x, the value for x, back into your original equation. So 2 to the exponent 2 times 3, does that equal 2 to the 6th? Well, 2 times 3 is 6, so we get 2 to the 6 equals 2 to the 6, so that checks. And the solution would be x equals 3. Number 14 is a little bit different because the base here is 4 and the base here is 2. So the bases are not the same. So what we want to do is to rewrite one of the bases so that they are the same base. Notice that 2 squared is the same thing as 4. So we can rewrite this 4 here as 2 squared so that the base here will be 2. So we have 2 squared, the exponent x equals 2 to the 6th. Now if we multiply the 2 and the x together, that would give us 2 to the exponent 2x equals 2 to the 6th. So now it's the same exact problem as number 13. So the bases are the same. We set the exponents equal to each other. 2x equals 6. And solve for x. Divide by 2. You get x equals 3. Again, it's a good idea to always check your work to see if your solution makes sense. So if we substitute the value of 3 in for the original equation, we will get 4 to the, right, putting 3 in for this x. 4 to the exponent 3, does that equal 2 to the 6th? Well, 4 times 4 times 4, 4 times 4 is 16, 16 times 4 is 64, and 2 to the 6th, 2 times 2 times 2 times 2 times 2 times 2, that is also 64, so that checks, and you can be content knowing that your solution x equals 3 makes sense and is the correct solution.